In today's video, we are going to talk about storage autoscaling with Azure NetApp Files. We'll start out by going to the storage menu and then the Azure NetApp Files menu, and we'll see that we already have an ANF volume on a capacity pool within an ANF account that's currently configured. It currently has 0 gigabytes that's used out of the total size of 4 terabytes. Now, a quick reminder about the way that Azure NetApp Files storage system works. You have an ANF account, which can have multiple capacity pools. Capacity pools are then created with a certain type of service level. You can have standard, premium, or ultra service level, which determines performance and the performance tiers. And then within each capacity pool, you can have one or more volumes that in aggregate cannot exceed the size of that capacity pool. The cost of an ANF storage is determined by the size of the capacity pool, with the minimum size being 4 terabytes. So you cannot create a capacity pool of less than 4 terabytes, and you can grow and shrink the size of the capacity pool in increments of 1 terabyte. But obviously you cannot shrink it to be smaller than the sum of all of the volumes that are contained within that capacity pool. The performance of an ANF storage system depends on the volume size, and the bigger the volume size, depending on the service level or the performance tier of the capacity pool within which it resides, that determines the performance of that volume. Now, with all of that as the background, let's go ahead and open up the autoscale configure page and go through the various configuration options that are available here in the Nerdio Manager. So the concept behind storage autoscaling with ANF is to be able to dial up the performance of a particular volume, and then during times of high demand on the storage system, and then dial it back down in terms of size when that performance is no longer needed. Now, this performance may be needed on a scheduled basis, for example, during log-on storms or log-off storms from Azure Virtual Desktop machines, or it could be needed when there is lots of activity sort of interday or midday on the storage system, and the latency on that volume is detected to be high. So what you'll notice is the first thing we have in this storage autoscale is we have the overall on and off button that you'll be familiar from other autoscaling pages in Nerdio Manager. Once we turn this on, then we have 3 sections that we need to configure. Section number 1 is called provisioned size. This is where you tell the system what is going to be your minimum and maximum volume size, and also what type of autoscaling mode you're going to be in. And there are 2 types of modes here. There's one that's going to autoscale the volume and the capacity pool that contains it. And that's going to be the one we'll cover today. And then there is also the option of only autoscaling the volume without autoscaling the capacity pool together with the volume. Now, why is this the default and the one that we'll be talking about? And the reason is that the cost of an Azure NetApp file system is determined by the size of the capacity pool, while the performance is determined by the size of the volume. So if we want to reduce the cost, we also have to shrink the capacity pool, not just shrink the volume. And if we are going to grow the capacity pool and there is free space in it, we might as well use that free space and grow the volume to fill the free space. So the easier scenario to envision is, imagine you have one capacity pool with one volume in it, and we are going to be growing the volume. And as it bumps up against the limit of the capacity pool, we're going to grow the capacity pool as well. Now, the key thing to keep in mind about growing and shrinking capacity pools is that the minimum unit or the increment is 1 terabyte. So you will see here under this tooltip that capacity pool size changes will be in increments of 1 terabyte. So pay close attention to the units that are specified for the various fields that you're configuring. So let's go ahead and select volume and capacity pool mode. Our unit size is going to be hard-coded to a absolute unit of a terabyte. And then we're going to specify the minimum volume free space that we want to maintain. So for example, let's say we want to always have 100 gigabytes or so of free space. So we will do 0.1 of a terabyte, which is going to give us always 100 gigabytes of free space. Now, what happens if the volume free space drops below this limit? The system will try to grow the volume, and if it can grow the volume within its current capacity pool, it will do so. But because we have the volume filling the entire capacity pool, that means that the capacity pool will also be expanded by 1 terabyte, and then the volume will grow by at least 1 terabyte to fill that capacity pool. So what this setting lets us do is it lets us always maintain a certain amount of free space in our volume without having to monitor it manually. The system will automatically grow things as needed to fulfill this condition. We also have a setting to prevent and protect us from sort of having storage space run away from us and continually grow and grow and grow. And that is why we have a maximum volume total size, which we can set to really any number up to, I believe, 100 terabytes. So we can set 100 terabyte volume size. But let's say we don't want this volume to ever get bigger than 10 terabytes. So we're going to go ahead and set the maximum to 10 terabytes. Now, this table over here is really useful to really understand what the performance and the size characteristics are going to be. And what you'll notice is we have 3 different columns here. We have our minimum size, our current size, our maximum size, and then various various rows. So for example, the first one is our service level, and we can see that we are at the standard service level. Our current volume usage is 0 terabytes, as we saw on the previous page. This is a brand new volume. Our volume size is 4 terabytes at a minimum. It's 4 terabytes currently, and it can be 10 terabytes at a maximum. That is because we have this setting specified here. And the reason it's 4 terabytes at the minimum is because that is the minimum size of a capacity pool. And because we're using this mode, the volume always fills the capacity pool. So you can see the volume size and the capacity pool size will always, the minimums will always be the same. And then we can basically see what our performance characteristics are. So the way throughput works, the way that, and throughput is how performance is determined, is for a standard service level, standard performance tier, it's 16 megabytes per second for every terabyte. So because we have our volume size is 4 terabytes, then our performance is going to be 4 times 16, which is 64 megabytes. Now imagine we wanted to set a volume minimum size to be 5 terabytes, which means that current usage is 0. So that gives us enough free space to fill this condition of 5 terabytes. Immediately, you can see that our capacity pool is always going to be 5. Our volume will be 5. And then our resulting throughput is going to be 80, 5 times 16. And then here are our maximums. So this is just a handy table as you're configuring this information throughout this page to give you an idea of what the minimum, maximum, and current sizes and performances are going to be. Let's go back to 0.1 in this configuration. Then we get down to the scheduled based scaling section. This could be turned on or off. Let's go ahead and turn all auto scaling off for a second. And if we had this configuration, the only thing that autoscale would be doing is it would be maintaining this condition of minimum free space. So it wouldn't scale out or scale in based on latency or based on a schedule. What it would do is it will scale out as the capacity and the usage grows. It would scale the size of the volume up to give it, to maintain the condition of maintaining this amount of free space. Now, a very common scenario is when you have users that are logging in the morning and logging off in the afternoon. And during those log on and log off storms, you have certain peaks in demand on the storage system. And this is where schedule-based scaling comes in. So the first thing we got to do is define the time zone, which is going to determine all of these times that we're specifying. And then we can have one or more schedules. So let's set up at least one schedule, and we'll say that Monday through Friday, between 8 a.m. and 10 a.m., we want to increase the volume size to a larger than current amount, which will give us a certain amount of performance that we believe we need in order to give users good experience. So let's say during logon storms, we want the volume to be 6 terabytes in size. And after this time, we want it to be shrunk back down, including the capacity pool that contains it, which is going to really save us those costs, as long as we don't violate the free space condition, which obviously in our case with zero usage, we will not. So that is going to accommodate our logon storm situation. Now, let's say we also wanted to make sure we have this extra boost of capacity during log off times. We will click this plus sign and we will set up Monday through Friday, but this time, let's say between 4 p.m. and 6 p.m. This is when users are typically logging off. And maybe at this time, there is even more capacity that needed. Maybe the FSLogix profiles are being merged. Maybe you're using concurrency with read-write profiles and things like that. So maybe we need the volume to be 7 terabytes in size during this time. So we're going to set up 6 terabytes between 8 and 10, and then 7 terabytes between 4 and 6. Now, if we had some special situation where on the weekend, we may be doing some sort of server maintenance and we need extra boost of capacity. So we could say that Saturday and Sunday between 12 a.m. and 3 a.m., we want to have 10 terabytes of volume size, which is what's going to give us extra processing and extra performance and throughput capacity. So we can have multiple schedules set up. They obviously cannot overlap. You're going to get an error if you try to save this configuration if they overlap. But in this configuration, we have a logon storm, a log off storm, and a weekend update process where the storage system will give us extra capacity, extra performance and throughput, and then scale it back down to save on costs. The second type of autoscaling is latency-based. So while this one was based on the schedule, latency-based scaling is based on looking at the current latency on the volume in Azure. And we have 3 different triggers we can use. We can look at read latency, write latency, or read or write latency as our trigger, depending on your use case and depending on what is the typical constraint. You will choose the right value. In our case, the default is read or write latency. And we're going to tell the system to increase the volume size by 1 terabyte. And this could be a bigger step. It could be 2 terabytes or 3 terabytes, depending on our scenario, but it's going to, in this case, increase it by 1 terabyte if read or write latency exceeds this many milliseconds for 5 minutes or longer. And again, all of these are configurable. This may be the right threshold. This may not be the right threshold. It really depends on what your use case is and what type of storage you're using. But 20 milliseconds is a reasonable threshold. And there's also a little hint here that tells you what the current latency is, because this volume is not used. Latency is 0, but if you had some activity, you would see what the actual latency is, and that could guide you as to what these settings should be. Now, once the latency goes above this threshold, the system will begin increasing every 5 minutes by this amount, growing our volume and its containing capacity pool up to a maximum specified right here. Once it gets to 10 terabytes, it will not increase it any longer. And then as soon as the latency drops below 20 milliseconds, it's going to stop increasing. And if the latency is now below 10 milliseconds, then it will actually begin scaling in or decreasing the size of that volume. Here too, it's going to do so in increments of 1 terabyte, and it will do so if the latency is 10 milliseconds for 15 minutes or longer. And again, here's our tip here that tells us what the current latency is. So with this configuration, let's go ahead and click Save and Close. And we have a setting that exceeds the maximum. So let's go ahead and change this. Okay, I think I set it to 10, and that exceeds the allowable amount. So it automatically removed it. Let's go ahead and add this back in. Saturday through Sunday from 12 to 3. And let's set this to 9 just to see that as an example. Let's go ahead and do Save and Close. And there is our config. So we can see here that we have a minimum capacity that we're going to maintain is going to be 0.25 of a terabyte. We're going to have a maximum size of 100 terabytes. We're going to scale out to 5 terabytes during logon, during log off, and on the weekends. And we're also going to scale out if we are above 20 milliseconds and scale in if we're below 10 milliseconds. So this is going to really maintain the level of performance at the optimal cost for us with Nerdio Manager and Azure NetApp Files storage autoscaling. Hope you found this useful, and I look forward to seeing you in future videos.